Hello, everyone. I'm Nate Stewart, CEO of Materialize, and today we'll be talking about real-world context engineering. So what are some of the things that go wrong when taking agents from the lab to production? And one of the one of my favorite parts about my role is I get to spend every day talking to engineering and data leaders about some of their most pressing challenges when it comes to building AI agents. And I'll be sharing some of those learnings today over the course of the next 45 minutes or so. So a couple things we'll talk about: AI agents in enterprise infrastructure. What are some of the changing workloads that people are experiencing today? We'll talk about context engineering, what it is, why it's important, and some of the ways you might think about that. And then lastly, we'll start to talk about some practical application architectures for your environments, and then we can wrap up with some next steps. So first, the big thing that we're hearing at Materialize as we work with large financial institutions or major manufacturing and logistics companies is that these agents that are coming online are incredibly context hungry. They want a tremendous amount of information about what's going on in your business right now. And that demand for fresh context is fundamentally breaking a lot of the data infrastructure that powers your core systems, whether it's your ERP, your transportation management system, your CRM. And I like to think about this shifting workload as a play in three acts. You have your Web 2.0 era where applications were typically built as monoliths. You'd have your single operational database, maybe it's a MySQL. You'd go to a website, you leave, you'd come back, and it would remember something about you. Generally, what's happening is, one human action, one click, one purchase is ultimately resulting in a single read and a single write, generally. And as we moved into the cloud era and people got access to unlimited storage, network, and compute, and they started thinking about different ways to build their applications. Okay, we're going to move from the monolith to the microservice. Think about the Amazon two pizza team. So now we have all these different services, and these services all have their own operational databases. Now we have these operational data silos. And by the way, now one human action, whether it's coming from a web app or a mobile app, that's going to start to fan out. So one human action can span across 10 microservices as caches and queues are being updated and all the state is being federated around. Maybe you're using a Kafka topics to move data back and forth. So you get this big fan out of your writes. And again, your reads may have to go to multiple services to actually complete the request. This is where new databases started coming online to deal with this increase in traffic. So think about your distributed databases like your DynamoDBs, your MongoDBs, your Spanners and CockroachDB. That's really where they started to come online. And now we're in this fundamentally new space where humans have multiple agents acting on their behalf. One human intention can spin up 10 agents, and those agents are all interacting with that same cloud era infrastructure. So you're getting this additional fan out effect where one human intention can turn into 100 microservice writes, 1,000 microservice writes. But the thing that has changed is you're not just seeing simple reads anymore. You're not seeing, give me customer 123 in order 456. No, these agents want 360-degree representation of your customer. What is everything we know about them? How are they interacting with our brand right now? Are there any ongoing tickets? What's the lifetime value of this customer, and how has it changed based off of some of the things that we've seen in the last few moments? This is a fundamentally different type of read workload. It's a complex read, and traditional operational databases just fundamentally were not designed to handle this, and it's causing a lot of things to break. And so the folks that we're working with, they tend to find themselves here. They've just started to keep up. They've just gone through their cloud transformation. But as they're looking out at their roadmap over the next month, over the next quarter, over the next year, they're realizing they won't be able to keep up with this agentic workload without some fundamental change. And so the big question then is, how can you transform siloed agent scale rights into fresh and trustworthy context? And by the way, do that without breaking your production systems. And this is a hard problem. So if you think about how people typically get started, you hear things like RAG, retrieval augmented generation, where you have these great large language models, these frontier models, but they don't know anything about your business. That knowledge is the data that is unique to you. And so there's this idea of taking large language models, combining it with the data that's unique to your business, and then when agent has a query, when a customer has a question, you basically say, okay, here's my prompt. I'm going to inject it with some unique data, and then have the LLM respond using that context. And that works fine for just doing a proof of concept, but eventually you'll start to see that if you use stale data, you can't do simple things like, let's say, a customer support interaction where you ask the customer to make a change, they make a change on your end, and then for the next step, you don't have the visibility to see, okay, was that change impactful? Did that actually change the state of the customer? You can try to keep all of that in your context window, but things start to break down in a hurry. So building agentic use cases with a traditional RAG approach ends up not actually creating a lot of business value. And that's where this idea of context engineering comes into play, where you're saying, okay, we have all of this data, it's spread across the enterprise. How do we get it into the right shape? How do we do it quickly? How do we do it in a way that's reliable? And then make that available very quickly to LLMs, whether it's frontier LLMs or open source models, and do that at a scale that makes sense for agents, both in terms of delivering great experiences, but also doing it with the right economics from a token cost perspective. So that's context engineering, and it's really hard to get right. So why is this hard? It's hard because you don't have a lot of great primitives. We talked about the issue with operational databases. They're slow and they can't handle these complex queries, but they do have your freshest data. So it's a good starting point. It's just very difficult to get it out in a way that an agent expects. And so you could try going through extract, load, and batch transformation process to your data warehouse, your data lakehouse. There you get very fast queries, which are great for agents. Your data is integrated, but the problem is it's fundamentally stale. And so if you really need a combination of fresh data and fast queries, you may try to build it yourself, build your own pipelines, maybe using a stream processor, but that gets incredibly complex and you end up with specialized or needing specialized talent. And so ultimately, if we take a step back and if we think about this this new stack that we want to provide, like what is a North Star metric that we can rely on or really use to guide our decisions? We'd like to think about the time to trusted action. How do you minimize the time between an event happening in the real world, whether it's an agent or a human in the loop, taking some action, and when that event is surfaced in the context that's made available to your agents and your applications? That is the time to trusted action. And the word trust is important here because you can do a lot of approximations, caching, and try to fuzz the numbers a little bit. But as these agent workflows start getting more and more complex, those shortcuts really start to compound, and you end up with extremely unreliable agents that aren't actually adding any business value. And the great thing about this approach is that if you can actually get to single digit second time to trusted actions, you can get these really powerful feedback loops where you can have agents that observe the state of the world, think using some of these great frontier models or even some of the open source models, and then take some action. And the action they take, whether it's on one database or across multiple databases, that immediately is reflected in their worldview. This unlocks a few things. One, you get great multi-agent interaction. So one agent can take one step of a workflow and another agent can take the next step, all while incorporating the previous work of the agent. So you don't have to do it in this ballooning context window. But it also unlocks these nice interactive experiences where agents and humans can team to accomplish tasks. So you have agents working and humans verifying, and it creates this really nice experience. But to do that, you need very fast time to confident action. So to show how this all comes together, we'll use an example from it's basically a composite of many of the different customers that we work with. It's a fictional same-day delivery service. You can think of them like a DoorDash. They have customers, they have stores, and then they have couriers that are moving things back and forth. They're built on a microservice architecture. They're thinking in terms of data products. So how do we go from raw data to these governed, you know, views or these governed data products that we can make available to APIs and increasingly to agents. And we'll see some of the challenges they run into as they're rolling out agents. So let's take a look at their application architecture. So in this case, they have their source systems. Maybe they're coming from different microservices, or maybe they're using Kafka, but ultimately they're staging it in this operational data store or this database that's basically their intermediate area where they're bringing everything together, and then they're running these queries. And they're taking this approach. Some people call it a medallion architecture, where basically they have the raw data that's coming in from these source systems, and they have a series of views that ultimately go from the raw representation of the different elements of their business into the actual contextual building blocks, the representation of a dynamic price, the representation of an inventory item that they can make available to agents. And so you have your rights coming in, and then when an agent has a question, all of that work is being done reactively. And this is extremely complex because the database doesn't know anything about the agent query ahead of time, and is trying to process all of these views when an agent has a question. This A leads to extremely slow queries, but B, it can cause instability. So these are two reasons why this architecture typically does not work for agents. And so we'll move into the demo so you can see how this works. So what we're seeing here is you can think of this as a view into Freshmart's data architecture. They made a couple different decisions here. They have this medallion architecture that I mentioned before. They have their low-level entries in their operational databases. They're applying a series of transforms. They're getting into these intermediate data products. And then ultimately, they're producing this data API response. And so if you look at how long it takes to go from a write to a read for a representation of an inventory item, which we have here. So this is just an example of a order. Just rendering this order, it takes about, what is it, around 6 or 7 seconds, right? So this is too slow for an online application, and this is just one query. If you did 1,000 of these, that system would be offline. You could try scaling it up or scaling it out. Ultimately, you're scaling an architecture that wasn't designed for this type of workload. So where you end up with is a situation like this. You have these very fast reads, but you have your very fast writes, but your reads are slow, right? So if we're just looking at a log scale of time to trusted agent action, this can be minutes to actually serve and assemble this context. And so you end up with agents that can write well. The operational databases are great at handling writes, but they can't actually see the results of their writes. So this is not a stable configuration at scale. So the next thing the Freshmart team tries is saying, okay, we have all of our sources. We need to integrate them. And we know there's a lot of work to be done. So this is a standard pattern for bringing in a lakehouse or a data warehouse. We have our source systems. We're going to extract and load them into the data warehouse. And then we're going to model those same views using that same medallion architecture. And then once an hour, once every 15 minutes, we are going to pre-compute these views. And then when the agent comes in, they will get very fast responses. So let's look at what that means for the architecture that we just spoke about. So here is the world where you are serving from a data warehouse. So we have the view from Postgres. We have a view that's served in batches. In this case, we're just using traditional scheduled materialized views in Postgres, but it's the same shape that you would see in a data warehouse. And so the team sees, okay, well, initially it took 7 seconds to load a order, and now we can do it in 70 milliseconds. So this looks great. This is cause for celebration. It looks like mission accomplished. But what will happen in practice is that over time, they'll start getting customer complaints. People are saying, hey, I ordered something, it said it was coming, and then I realized it wasn't there because the item was out of stock. Or, okay, yeah, you have this dynamic price, but the price I saw on the website and the price that I saw on my bill was different. What's going on here? And what's going on is, while this chart is showing the response time, how long does it take to return an agent query, it's not showing the end-to-end reaction time. And when you look at that, you see a shape like this. So essentially, this green line is the freshness, or the time between an event happening and when it shows up at the other end of an agent request. The data is pretty fresh the instant one of those batch processes run, but every second after that, the agent's context is drifting further and further from reality. And this causes a ton of issues when it comes to customer satisfaction and even your ability to have humans and agents team up. But this is just the state of the world. You have to make this fundamental choice between fresh data, like you had with your operational databases, and fast queries, which you get with your data warehouse. And so what does that mean for your agents? Now you have your writes take a bit longer. You're staging them through S3. You're landing them in that raw area in your data lake. And then you're going through this batch process. So now this can take many minutes. In some cases, it can take hours. And you're doing all of that just so you have fast queries. This is where most people start with their production agent deployments. They're able to read very well. This is where you see a lot of the BI style agents, where you ask the agent a question, it goes out and gives you an answer. It's like an analyst style agent, but it fundamentally can't reflect the actions that you take at a given point in time. So now let's get specific on practical architectures for the enterprise. Like, what is a path forward? And what we've learned by partnering with forward-thinking enterprises as well as AI native startups is that there's this new approach, this new reference architecture that is increasingly being rolled out in production. And there's three main parts to this reference architecture. You start with your operational databases, and you make sure that they're tuned for high write throughput. So your scale out SQL databases, your MongoDBs, DynamoDBs, any type of database that is designed for handling high write throughput, that is a good starting point, because databases are very good at correctly handling transactions. So let them do what they're good at. We've been saying how they're not great at doing complex queries. And so what we're going to do is find a way to integrate and transform those writes into live context and make it available at agent scale. This is something that's easier said than done, but that's generally what you want to get to. It has a lot of benefits, both in terms of performance, but it also, in more advanced cases, can have big implications for how efficiently you can use tokens, because you're not spending as much time trying to figure out how to join two different tables together just to create this composite representation of a customer. The agent can just think in terms of a flattened, governed customer table. So that's the next thing, getting to this semantic layer, basically creating this live context and make it available at agent scale, or real-time context. And then in the most advanced cases, you then layer in a knowledge graph. And essentially what this does is says, okay, we have these contextual building blocks, we have these data products, but if we know a little bit about how these data products are linked, what is the relationship between a customer and a supplier? What is the relationship between this order and this warehouse? If you can start to create those semantic links, it gives your agents a very powerful roadmap for figuring out what to do next. So rather than just asking one question, they can really start to explore your business and figure out what's the most optimal way. What are the different tools? What are the different questions to ask to actually deliver business value? So this is a knowledge graph. Some people call this an ontology, but these are the three big building blocks. And we like to think of the latter two as a context graph, right? A real-time context graph or a live context graph. So this is what ultimately we're building towards. And that's what we'll be talking about for the rest of this session. So let's start with the live context, these contextual building blocks. So this is the hardest part. Like, how can you integrate data and do it in a way that's fast and fresh? So this is fundamentally rethinking your data supply chain. And one of the ways I like to do this is by getting inspiration from people who have taken a fresh approach to the physical supply chain. And my favorite example of this is Chipotle. So what does Chipotle do? What did they figure out? Well, their whole thing is, how can we give you food that is both fast and fresh? And the way they do that is they're continually bringing in raw materials into the different stores. If you go to a Chipotle and you look in the back, you'll see there are some folks working in a kitchen. And it doesn't matter if you're ordering something, it doesn't matter what you order, they are in the back and they are continuously taking raw ingredients, doing some amount of work to them to transform them into semi-finished goods. So they're taking the raw chicken and turning it into grilled chicken. They're taking the avocados and they're turning it into guacamole. But they're not delivering your whole order. And what the key thing that they're doing is not just creating these semi-finished goods, is figuring out, okay, based off of the menu that we make available to customers, that they make available to customers, what is the set of semi-finished goods that we need to have so that no matter what you order, we can have it ready, right? So if you look at those bins in a Chipotle, there is thought behind it. What is the minimum set of bins to give you the most valuable menu options, right? So there's this thoughtful thinking about these semi-finished goods, which ones do we want to have, and then use that to give you the most flexibility for your menu. And essentially they have this big proactive component. And then when you order, they quickly assemble your burrito or your taco. So they have this reactive component, right? So they're doing a ton of work proactively rather than getting everything started as soon as you place your order. So that's how they deliver fresh and fast food. What if we take the same idea and apply it to your data infrastructure? Well, we would continually integrate your data. So as your data is changing, we would continually stage it somewhere. And then as that data is being staged, we're not going to wait for someone to ask a question. We are going to continually transform it into data products, real-time data products. And this was physically impossible to do just a decade ago. There was some new computer science that had to be invented to pull this off. This is the idea of incremental view maintenance, and it was pioneered by the Materialize co-founder, Frank McSherry. But this idea of continually transforming raw data into live data products is one of the key steps to pulling off this more proactive data supply chain. And then data products require data product management. What are the representations of your business that, if provided, would give your agents the most flexibility and the most power to do those most valuable use cases? So you're taking these raw data, continually transforming it into live data products, and then when an agent comes in, you can quickly assemble those into context. And so If we look at how that plays out, going back to the FreshMart example, if we take these ideas of taking raw sources, incrementally transforming it as the data changes and going through this full medallion architecture from bronze to silver to gold, well, then you can do that in single digit seconds, in some cases less than a second, and then you make it available to agents. If you do this, you get fresh data and fast queries at the same time. Okay, so let's take a look at what some of these ideas look like in practice, going back to our FreshMart example. So what we're seeing here is, we have the same data product now calculated three ways. We have it, the order calculated directly from Postgres. We have it using a batch process, and then we have it using some of the ideas that we spoke about. And when you do that, you'll see a couple interesting things. The first is, as expected, because we're doing some work up front, we have fairly low latency. So, this is just running in a emulator or a demo environment. It doesn't have a lot of machinery behind it, but it's still, orders of magnitude faster than what we saw in the Postgres example. So in production, you can see single digit milliseconds for reads. So basically, you're getting reads that are closer to what you saw in your OLAP system or your Lakehouse. But the thing that's really surprising here is you're getting those reads without this stair step of staleness, right? So your reaction time, the time between an event happening in the real world and when it shows up at the other end of one of these data products, is extremely fresh. And one of the things to see here is that the line for reaction time is beneath the reaction time. Sorry, the line for reaction time using these approaches is actually beneath the reaction time that we were seeing from a core operational database. And what this means is, surprisingly, you can write to an operational database and see the results on the other end of a live data product faster than if you had read directly from that operational database itself. And it's because by doing work incrementally and not waiting for the question, you can get such a head start that you can respond faster using these approaches than querying directly. Now, and I'll just give you a quick example of this. So here, again, we have the three orders. There's two things in the shopping cart, and I'm going to change the value from this order line. I'm going to change the quantity to 99. So the way this works is everything writes into the Postgres database. That is your system of record. But the reads happen in three different ways, right? Postgres, batch process, and from materialize, which uses the ideas that we're talking about here. So watch what happens. I'm going to write to Postgres, and it shows up in materialize first. And then 6-7 seconds later, you'll see the result in Postgres while it's still trying to do all of the work to calculate that value. That's very surprising. So again, we are going from these raw updates all the way to these gold data products in less than, or in a second or two. So that's the power that you get by doing work proactively rather than when you have a question. And so going back to our example, minimizing the time to trusted agent action, your writes take a little bit longer because you're writing to your OLTP system and you're replicating out of the OLTP system into someplace else. But because as that write happens, you're going through all of those transformations incrementally, you've done so much work that when the read comes in, it's just as fast as your data warehouse. So you basically get the best of both worlds. You get the write latency of an OLTP system with the read latency of a data warehouse. You push those together, and now you have a time to confident action or time to trusted agent action that is single digit seconds. And you finally get into this goal state of being able to have an agent write and then instantly see the results of those writes, which unlocks the human agent teaming and the multi-agent workflows. So now let's see what this looks like in practice. What we're going to do here is we're going to act as a customer service rep that has an agent co-pilot, and we'll say, someone's chatting and they, I have a user named Stuart who wants to make burrito bowls enough for an office party with 50 people. Please create an order with the necessary ingredients. And so when we do this, the agent is going to take a look at the inventory that's available. It is going to combine that with the knowledge, the general knowledge from a large language model around, okay, what even is required to make a burrito bowl. And then based off the inventory level, or based off the inventory levels and the various business logic to actually determine the right pricing and things like that, it is going to assemble one of these orders. And so it's saying, okay, here's the dynamic price, here's what's available. Again, each one of these orders would take 7 seconds to calculate with all the business logic that we saw using Postgres. It just has access to this instantly. So most of the latency now is coming from the large language model itself. And it's like, would you like to proceed with placing this order? I will say yes. And then again, most of the waiting now is just going through the large language model. So it's actually saying, hey, I don't have an ID for Nate Stewart. Let's see, create an account for him. Okay, so it's going to create the customer. And by the way, this whole thing is live. So right now there's 9 orders that are created in the system. We can see it just went to 10. And then if I search for this order number, we can see it is created, and here are the ingredients. So the sour cream, for some reason it said green beans, guacamole. It looks like they made some substitutions, some lettuce, and that's what it thinks we needed for a burrito bowl. And the other thing to highlight here is that, as I do things like, let's move this order status to delivered. What the system does is it says, okay, you made one change. You change this order status from created to delivered. And when you did that, it instantly figured out throughout all of the inventory, everything going on, all these dynamic pricing business rules, what needs to change. So it's saying, okay, well, we just had this salsa, ordered a bunch of those. Because of the things we ordered, we're actually going to change this dynamic price. Here's the nature of the price change. Here's why it was slightly more popular. The product sale increased just a little bit. And all of this business logic that would take hours to do in a traditional data lake, you're having this entire thing flow through the system in less than a second. So it's incredibly, incredibly powerful. And so essentially what you're doing is you're going from this place where initially you could take these views and ultimately create this semantic representation of your business. If you create enough of these building blocks, you end up with essentially a digital twin of everything that you care about. Normally, this would have to live in the data lake. And with these ideas that we've been talking about in this session, you can move this entire digital twin into operational space. You can keep everything you need to know about your business, this whole, these real-time data products. You can keep all of these up to date in less than a second and then make that available to agents. It's incredibly, incredibly powerful. Okay, and the last thing I'll cover as we're wrapping up is this idea of a knowledge graph, right? How do we link these together? And so in the case of Freshmart, they have a knowledge graph where they have said, okay, here is how an order line is linked to an order, and orders can be placed by customers. So they have the data products, which we've been talking about, but also those semantic links. Some of the folks that we work with, they build these ontologies by hand. Others in that are a little bit more advanced, they actually have agents voting on the edges themselves. Like as they learn more about your business, they're saying, hey, I think these two things are related this way. And then they're actually using some of these ideas to apply business logic to the edges of this knowledge graph to say, okay, based off of everything we know at this moment in time, here's what we think the canonical link is between these two things. So now you get this living, breathing roadmap of your organization that is used by agents, but also informed by agents, overridden by humans in the loop where necessary. And it just creates these really, really powerful agentic experiences. And so for the last demo, I'll switch back to our demo application. And now what we're going to do is we're going to start some demand. So the whole thing with Freshmart is they have demand that comes from the customers, and they have the supply of the couriers and the restaurants for meeting that demand. So if we look at the couriers, now we see, okay, orders are being placed and they're moving. They're going from being available to shopping, to picking things, to being in delivery, to routing. So they're going through all of these states, and all of this stuff is moving around very quickly. And if we look at the metrics here, we can see we have these different views where it's like, okay, what's the dynamic pricing yield? Like how much are we making based off of the lift that we're getting from these from our dynamic pricing algorithm based off current inventory levels? What's the revenue at risk, store utilization, things like that. And then because all of these are different views of the same underlying data, we can cut it by different ways. What's my store capacity? Any high risk inventory? What's going on at a per store level? And so now, stepping out of the agent scenario and into the executive scenario, you could say, look, this is a lot of information. I don't 100% know what to do with all of it. It's moving a lot faster than any human can make sense of. But I can do something like this. Let me just make this a little bit bigger. What do I need to be paying attention to in my business right now? And so what's going to happen is the first thing the agent is going to do is say, okay, I'm going to get the context graph. I know these data products, but how are things related? This is a big question. Like, how do I walk the business and understand all of the different elements? And then from there, I may call some tools in addition to running queries directly. So I'm saying in this case, I'm going to get the store health as a tool in addition to my normal queries. And it's like, okay, well, currently, it looks like all of these stores are underutilized, but there is some critical inventory. So based off of what's going on right now, here are the 63 products that are critical, and here's what's at risk. So this is an example of the power of having agents that have access to this live digital twin of your entire business. You can deliver those customer-facing experiences. You can deliver those internal tools like we saw with the customer support experience, but you can also get this executive co-pilot that can help you with the biggest decisions based off of the changing and evolving view of your business in the moment. So these are just some examples of context engineering in the real world. There's a lot of ideas behind this, and that's really what we focus on at Materialize. We basically built a platform around these ideas, that incremental view maintenance. We've combined it with some other techniques. So we're not doing approximations. We're making sure that as the world changes, you are moving from consistent state to consistent state, and that lets you transform those siloed agent scale rights into fresh and trustworthy context. We've had a lot of design partners as we've gone through this journey, from Crane Worldwide Logistics to General Mills to Mercari, and we're backed by some of the best investors in the world. So practically, you don't want to just go for a full digital twin and build this whole semantic layer. That will take too long, and you're not going to see the incremental wins. How you typically adopt these ideas is you have your operational databases, you have your data lake, you're just going to add a speed layer. You're going to say, okay, here's a couple high value use cases. What are the minimum set of data products I need to make those available at agent scale, right? Similar to the Chipotle example, what are the minimum semi-finished goods that I need to start to unlock some new agentic experiences? Maybe it is just, hey, it's too expensive to ask these very basic questions of my ERP because of the way my SQL Server database is organized. Okay, well, I'm going to create a canonical representation of an order that applies all of that business logic, and I can make that available to my agents or my applications. Now, this works really well. The challenge with this approach is that you end up with these two definitions. You'd have a definition of an order for your speed layer, and you'd have a definition of an order for your lakehouse. And so ultimately what you do is say, okay, I'm going to move to this world where I have this live canonical representation of everything that I care about that I can make available to agents or make available through APIs or event-driven architectures or just for my data intensive UIs or operational dashboards. I have this canonical view, and then I'm going to just push the exhaust into my data warehouse for historical analysis or training models and things like that. And so now you get one definition, one live view of your business, but you still have access to all of that all of the power of your data warehouse. And the benefit of this is that if you're spending a lot of cycles trying to do batch processing faster and faster, your bills are probably extremely, extremely high. Because you do work in proportion to the amount of data that changes with this approach, you get radically better economics for keeping up with the world as it changes. And this idea of thinking in terms of data products really gives you this powerful compounding effect where it takes maybe a couple days or a week to get your first use case up and running. But as you add more data products, similar to the impact on a menu as you add more bins in our Chipotle example, you just get this compounding effect where you can do more and more things, unlock more and more experiences, build more powerful agent tools as you add more use cases, as you add more data products. And so with these approaches and ideas that we spoke about, it's the way to get from this really difficult point of seeing agents coming online and not quite having the building blocks to being able to keep up with this new curve and deliver the types of experiences that your customers and your shareholders expect. So one of my favorite quotes just to wrap up is from the team at Day AI. They're basically rebuilding the CRM to make it agent native. And they use these ideas to take the raw truth as understood by agents. So they're capturing a massive amount of data, but they couldn't capture it in a way that could both keep up with agent scale rights and make it available in a way that agents could use and do it in a way that's also flexible. And so just using SQL, they could go from the raw truth that the agents are collecting to these live representations of context that match how an agent would want to read it. And again, because these ideas are just using SQL, it's very easy for your existing team to get up and running. So just to conclude, agents are multiplying the read load on your operational databases by orders of magnitude. And if you think about this idea of minimizing time to confident actions, so you can get these feedback loops, whether it's multi-agent workflows or humans in the loop, you can do it by doing some of the work up front, getting to a place where you can build these real-time data products that can unlock different experiences. And you don't want to bite off everything all at once. You want to get wins incrementally. Start with a small set of data products, deliver your first agentic use case, and then start to build from there. So thanks so much. That's everything that I had for today. Here's a link if you want to schedule the demo, but I'm going to open it up for some interactive questions. Hey everyone. All right, I'm just seeing a couple questions come in. I'll just give folks one more moment. Okay, so there's one question around when to use Materialize or when not to use Materialize. The big thing we see is that if you have, ad hoc queries, so you want to do things like data exploration, that would not be a good fit for Materialize. You would want to use something like a data warehouse. So Materialize is for when you can basically take your silo data and transform it into views that represent those core entities that you want to keep up to date. From there, you can still do ad hoc queries on the results, but for just doing data exploration on the data that's in S3, that would not be a good use case for Materialize. The other big decision point is how much data to keep in Materialize. So in general, our rule of thumb is that if a data source can fit into an operational database, so you're talking about many tens of terabytes, that's something that fits into Materialize. But once you start getting into the petabyte scale, in terms of economics, it would make more sense to use something more, again, like a data lake. Okay, there is another question around how this is different from, say, a federated query engine. We get this question a lot, and the core idea here is that with a federated query engine like a Dremio or a Starburst or something like that, this is great for analytics and doing queries that can fan out across multiple databases, so that still can give you a single view of the world. The challenge is if you're trying to get very low latency responses and you are trying to minimize that time to confident action or time to trusted agent action, if you're federating the queries out, you're actually putting a load on those operational databases. So you're basically, again, doing work reactively in order to get an answer, where Materialize, we flip that idea on its head, where we basically are getting low-level writes from the operational databases, so through your CDC feeds or through Kafka. And as those writes come in, we're doing a very small amount of work to keep those views up to date. So it's almost flipping the idea of a federated query on its head. And so again, it's very good for those online style use cases, your context engineering, your data intensive UIs, your event driven architectures. That's really where Materialize fits in. Okay, and I think we have time for one more. I see. So there's one question around MCP and the role that plays. So at the end of the day, Materialize provides a SQL interface to these real-time data products, and we have an MCP server that essentially lets you turn those tables into context. And so essentially what you do is, when I say tables, I mean views or data products. You basically will annotate these data products using your standard SQL comments. So annotating the data product or view itself, annotating with comments the columns itself. And then we have a tool that basically says, okay, what are the data products that are available for me? So any agent that has access to MCP, they can say, and they can discover that, okay, if I need a real-time or a live view of the world, I can get those live data products from Materialize. Otherwise, I can go with the batch process. And so this is really important, because if you ever have a situation where you have agents and you are saying, hey, you can appoint an agent at an operational database, but whatever you do, make sure it doesn't join. If you have those types of things where you're worried about the agent load on a database, using an MCP server with Materialize is just a very fast way to make those data products available to your agent ecosystem. Okay, so it looks like those are all of our questions. Thank you so much for joining the webinar. Again, if you have any additional questions, don't hesitate to reach out or schedule a demo. Thanks so much.